Alright, so we're going to start with some notes for section 4.2. Please write this down. We have a unit circle. Unit circle is a circle with a radius of 1 unit. So the radius is 1 in a unit circle. It is drawn with its center at the origin of a coordinate system. If this is the case, then the following coordinates can be identified. So you should have a little diagram there on yours. Okay, now the equation of the unit circle is x squared plus y squared equals 1, based on the Pythagorean theorem. Because if you drew a triangle anywhere in here, it would have an x value and a y value and a hypotenuse of 1. So we can say that x squared plus y squared equals 1 squared, or 1. So again, we're just really looking at this as if it is a triangle, and then if you move that anywhere around the circle, it would still have that same equation, x squared plus y squared equals 1. Now, if it wasn't a unit circle, but it still has to be located at the origin, then we could say that x squared plus y squared equals r squared, where r represents the radius. Again, for that same reason, it's based on the Pythagorean theorem of a squared plus b squared equals c squared. Alright, so again, to determine the equation of the unit circle, you could put any point on there. We could call that point x and y. And if I just connect that point to the origin, again, x, y can be any point. So I connect it to the origin, and I make a reference triangle by drawing the side length down to the x-axis. So again, this is x, and this is y. So then this is going to be 1. But again, if this is not a radius of 1, we could say that this is r, representing any radius of any size circle. Alright, let's try example 1. So here in example 1, it says determine the coordinates of all points on the unit circle that satisfy the following condition and draw a sketch of each situation. So here we have the x coordinate is 2/3. So if we're thinking about this in terms of the circle as a unit circle, which means that the radius is 1, x is 2/3 would be like somewhere in here. Okay, that's my x value of 2/3. So really what I'm looking for here is I've either got a point up top here, oops, right here, or underneath, maybe right here. So I've got either a point up at a positive y value or down at a negative y value. Now we know the equation is x squared plus y squared equals 1 because it's a unit circle. So all I have to do here is plug in 2/3 for x. So we're going to get 2/3 squared plus y squared equals 1. Now 2/3 squared, when you square the top and the bottom separately, you get 4/9. And then I would subtract 4/9 to the other side. So when I subtract it over to the other side, we get y squared equals 1 minus 4/9, which is 5/9. And now how do I get rid of that square? Square root. So when I square root both sides here, you end up with the square root of 5 over the square root of 9, which is 3. So square root of 5 over 3. Now be careful. When you square rooted something, that should have been a square, okay? That means you have to say it could be the positive root 5 over 3, or it could be the negative root 5 over 3. And that should make sense according to the question we had up here, because we said that the y value could be up at the positive point or down at the negative point. So we have two different options for y. So for part B, again, what we did is we used a squared plus b squared equals c squared. But this time we had a y value of -1 over root 2, and we knew it was down here in quadrant 3. So when we went through and solved, we got an answer of plus or minus 1 over root 2. Now I have to choose the negative because I know that it's in quadrant 3, and I can't have a root in the denominator, so I multiply top and bottom by root 2. So the x coordinate is going to be negative root 2 over 2 for your final answer. Yes. Okay, so let's look here. We have a point that's at minus 3 and 7. So first of all, let's figure out where the point is. It's on a circle. Minus 3 is an x value, so somewhere over here. And then 7 is somewhere up here as a y value. So your point would be somewhere over here on the circle. Okay, on the circle, not off. My pen is just not working right. So now we're going to find the radius, because again, I know x and I know y. I have to find the radius. So we're going to go x squared plus y squared equals the radius squared, because the radius would be like the hypotenuse. If you had made this a triangle, it would be like the hypotenuse. So we're going to go minus 3 squared plus 7 squared equals r squared. Minus 3 squared is 9. 7 squared is 49. And that equals r squared. So what that means is that we have 58, which equals r squared. So when we square root both sides, we end up with root 58 equals r. Okay? Now, good question. Does this have to be plus or minus? Technically, whenever you root something, you do get the plus or the minus. But when we're speaking about radius, radius is going to be always positive, because the radius is talking about the distance of the center to the outside of a circle. It's talking about distance. So we never speak of distance as a negative number. So we're just going to get this as a positive root 58. You also must keep it exact, meaning I don't want any decimals in this. You keep it as the root. So again, the x and y, those can be negatives, because we're talking about where it's located. But the radius is going to be always positive because it's the radius of a circle. All right, so step 1 with creating a unit circle is we're going to have to put the angles on our circle. Let's start with degrees, because degrees is going to make the most sense for you guys. We'll do the radians after. So let's start with degrees. The first special angle that we have would be 30 degrees, then 45 degrees, then 60 degrees, then 90 degrees. So those should all be pretty easy. Now, we're going to keep going. So think of it, first of all, let's do our multiples of 30. So we'd go 30, I'm going to skip 45. Okay, so 30, 60, 90. Then I would have 120, 150, and 180. So I'm skipping my 45 degrees right now, and I'm just going to count my 30s, first of all. After 180, you'd have 210, skip over the 45, so we're at 240, and then 270. After that, we'd be at 300, skip over the 45, we're at 330, and then come back to the top at a 360 degree angle. So again, I like to count my 30s first, and then let's put our 45s on. So now we're going to go to those middle ones. So starting here at 45, then we go 90, then the next 45 would be 135, and then 180. Add 45 to 180, so we get to 225. Add 45 to that, we're down to 270. Add another 45, so we get to 315. Add another 45, so we're back up to 360. So again, you can count by 45s and count by 30s, which is kind of the easiest way. Okay, so let's put the radians on. So we already said that 30 degrees is pi over 6 radians. I am going to use a different color for this. You may want to as well. So radians is pi over 6 radians for 30 degrees, just by converting it. Now let's count every 30 degrees. So here we have pi over 6, or 1 pi over 6. Then 60 degrees would be 2 pi over 6. But if I reduce 2 pi over 6, that gives me pi over 3. 90 degrees is 3 pi over 6, which when you reduce it is pi over 2. 120 degrees is 4 pi over 6, which when you reduce it is 2 pi over 3. Then I'm going to skip the 45 degree angle and go to my next 30 degree angle. So 150 degrees would be at 5 pi over 6, and then 180 would be 6 pi over 6, but when you reduce it, 6 pi over 6 is just 1 pi. Keep going. After 6 pi over 6 would be 7 pi over 6, then 8 pi over 6, but 8 pi over 6 can be reduced to 4 pi over 3. 270 then would be 9 pi over 6, but 9 pi over 6 can be reduced to 3 pi over 2. After 9 pi would come 10 pi, so we have 10 pi over 6. But 10 pi over 6 can be reduced, I should say 5 pi over 3. Again, 10 pi over 6 gets reduced to 5 pi over 3. Then we go to 11 pi over 6, and we go back up to 12 pi over 6, which remember is 2 pi. So again, pi is at 180, 2 pi is at 360, and then we're filling in between. We're then going to do the same thing with our 45s. So now let's put our 45 degrees on. 45 degrees is pi over 4, or a quarter pi, so we'll count in 45 degrees. So 1 pi over 4, this is 2 pi over 4, but again I've already reduced it. Then we're at 3 pi over 4, 4 pi over 4, but it's already been reduced, 5 pi over 4, 6 pi over 4, again reduced already, 7 pi over 4, and then up to 8 pi over 4. Already reduced, yeah. Alright, so how do we put these coordinates on? We can think about our special triangles. So if you think about a 30-degree special triangle, sine 30 would be 1 over 2, cos 30 would be root 3 over 2, and then tan is 1 over root 3, which when you get the root 3 out of the denominator becomes root 3 over 3. Now where do we go with this? Well, sine is going to represent your y value. So the y value is going to be sine, and the x value is going to be cos. Because sine is opposite over adjacent, so the opposite is going to be representing the y values. Opposite over hypotenuse. So sine represents the y values, and cos represents the adjacent values, which adjacent is your x values. So let's go back then and look at sine would be 1 over 2, and cos would be root 3 over 2 at 30 degrees. So 1 over 2 and root 3 over 2 at 30 degrees. Let's then do 45 degrees, following the same process. So both sine and cos at 45 degrees turn out to be root 2 over 2. So we can then put that value in. So that would be here at root 2 over 2 for cos and root 2 over 2 for sine. Now let's go back and find our 60 degrees. So looking here at 60 degrees, so sine 60 should be root 3 over 2, and cos 60 is 1 over 2. So let's put that last point on. So we have 1 over 2 and root 3 over 2. Now the rest of the circle should be really easy because it's just going to follow a pattern. So all of your 30-degree reference angles are going to have the same sine and cos coordinate, the same x and y coordinate. So I can put in all these other places that same root 3 over 2 and 1 over 2 from the first point. So all of the other places that have a denominator. No. Sorry, hang on. So I'm going to put the same point at all of my 30 degrees spots. So the root 3 over 2 and 1 over 2. Now the only thing that changes is the signs. So remember that last year we also did the cast rule, which was a smart trig class. And this means that in quadrant 1, all is positive, but in quadrant 2, only sine is positive. So I have to make here the cosine negative. Quadrant 3, tan is positive. That means both sine and cos are negative, so we need negatives in here. Quadrant 3, cos is positive, so I need to make sine negative.